Today we are going to discuss about how to configure the new rack in 3500 system configuration software. So for that we need to click on File and select New. It will ask to create a new virtual rack. You need to click OK. So here are some configuration we need to do at the startup. So first we need to select the communication module, that is either TDI, transient data interface module, or rack interface module. Rack interface module is serial communication module, and TDI module is also serial communication module having advanced properties than rack interface module. Second, we need to select the system type, that is standard and redundant. If you select the redundant, then it will come in triple module redundant format, means 3 modules will be selected. This configuration is selected for very critical applications. Normally in steam turbine or gas turbine we didn't see TMR type. Okay, where there is necessary, there is a decided in engineering, at that time we will select the TMR configuration. Here we will select the standard. And third one is rack size. So rack size full or mini rack. So full rack contains 15 slots and mini rack contains 8 slots. So first I will select the mini rack 8 slots. So you can see 1 to 8 slots are selected. So if you select 15 slot, then 1 to 15 slots will appear. So depending on the IO count, inputs and output count, we will select the rack type. Okay, so here power supply module and rack interface module, that is TDI. Okay, here we have selected at the start. So first of all, in power supply module we have 4 options available: AC high voltage, AC low voltage, DC high voltage and DC low voltage. In AC high voltage we can select the power supply as a 230 volt AC. So this module will convert 230 to 24 volt DC. Second one is AC low voltage. So here 110 volt AC can be converted to the 24 volt DC. And third one is DC high voltage. Okay, this is 125 volt DC module, where 125 volt DC will convert into 24 volt DC. And this is the DC low voltage from 15 volt to 30 volts. Okay, so in this range we can select the DC low voltage. So depending on the power requirement, we need to select the power supply module. Similarly, for redundant module also we need to set the power supply. So let's take an example. We are available with 125 volt DC. So for that we will select the DC high voltage, and second one also DC high voltage. Okay, so these are the primary modules, power supply module. Then here comes the communication module. So right click on communication module, click on options. So here are some parameters we need to configure. So this is the IO base option. If it is connected in fiber, then we need to select the base fiber. It is normal connection, then 10/100 base T. Okay, this slot available in the back of IO communication module. So next, here is network device name. So whichever the project is, we need to configure the same. So suppose we will give as NTPC. Okay, third one is rack IP address. Here we need to configure the rack IP. So whatever the all networks are communicated inside the same class, we need to define. So we will set as 192.168, some 52 and 23. So this rack configured in class C format. We need to give the subnet mask. So this is the subnet mask. Default gateway is optional. If the IP addresses are already defined, subnet mask already defined and gateway addresses are already defined, then we can put it here. Okay. Third one is external modem. So we are not connecting anything, so we will put it as none. Okay, rack mounting option, yeah, panel mounted. Power supply option. So whatever the power supply we have selected first, it will be appear in this region. Top is DC high voltage and bottom also DC high voltage. We can change it here AC high voltage if it is different. Okay, so here we will put the same. Then this is the connect password and this is the configuration password. If you want to put some password protection for downloading, for doing the configuration changes, we need to put it here. Okay, so right now we will not configure it. Press OK. So configuration for the TDI module is completed. Now let's say this rack, we are configuring this rack for the steam turbine application. So steam turbine, if steam turbine contains 4 bearings, steam turbine having 2 bearings and generator having 2 bearings, then there will be total 4 bearings. For that we need to configure 4 channels for turbine and 4 channels for generator side. So in this 8 channels we will configure the vibration, okay, which is proximity type. We are accepting the vibration from 33 XL probe through proximeter and connected it to the IO modules of the respected proximity module. So first we will add the monitor module. So right click on blank slots. Here multiple options will available. So first option is monitor. So here we can add the number of monitor modules. Whichever we required, we will add it. Okay. Second one is gateway option. So this is the third party communication module. So either you need to select 90, 91, 92. Both are. This module possesses the capacity of transferring the data through serial form to the DCS. Next one is display module. So if you are having any HMI module, that is display module, along with the panel of the rack or at some distance from the rack, then you need to configure either of this module. Okay, next one is Phasor module. This is the very important module used for balancing of steam turbine. So it is provided in the separate manner. So if we select the 25 Phasor module, then upper, either you need to put it in upper or lower or both upper and lower. This option will add the 2 Phasor modules. Okay, so we will delete first. Yes. So if you need to add only one Phasor module in the upper slot, you need to click on upper. So similar for the lower slot also. You can add the Phasor module. Okay, next option is relay. Okay, this is the alarming module. When you are accepting the vibration or position input from the steam turbine through proximity modules, then we will convert, it will be compared with the predefined set point and then output will be generated for the tripping to the DCS or directly to the steam turbine. So first option is 32 channel relay module. So this is having 4 channel only, and third one is which is having code of 33 having 16 channels. Okay, 16 outputs can be defined in this module. Next one is earthing IO module. So this module you need to install if the application is intrinsic safe. Means we are putting this rack for intrinsic safe application where hazardous area is available. At that time we need to put the earthing IO module so that there will not be any hazard if short circuits happen in the field or in the rack also. Okay, and last one is no module. So if you had some module, okay, like this, and you want to replace it, then you can cut it, or you can press the no module option. Like this, no module, sorry, no module. Okay, it will replace the blank slot. So now we will consider the turbine having two bearings and generator also having two bearings. For that we need to configure the 8 vibration channels. So we will right click on monitor, right click on blank model, select the monitor and select the proximity seismic monitor, which is 3500 by 42M. This M series is a recent modules having some advanced properties than this 42 module. So recently all the racks are coming in the /42M, that is M series format. Okay, so we will select that one. Okay, similarly we will add one more, since we are configuring the 8 channels. Now we will configure that channels. So right click on module and first we will configure the point names. That is, first we will put as turbine front bearing. Okay, only 20 characters. So similarly, turbine front bearing, one is at right side 45 degree and one is at left side of 45 degree. Okay, similarly for rear bearing also. Click on copy paste. Press OK. So we have configured the point names. Okay, point names will appear when we click on that option. Second one is we will configure the channel. Now click on options. So first one is radial vibration. Okay, we are measuring the radial vibration. Now we will configure the channel 1. So click on options. Here multiple options will appear. Okay, first one is zero position, that is gap. Here we cannot adjust anything, so we need to adjust the probe in such a way that at zero position of turbine we must get -10 volt DC gap voltage. The second one is, this is the full scale range. So whatever the probe range is available, we need to select that one. So here multiple ranges are given. So for here we will select the 3300 8 mm. Okay, 3300 XL 8 mm proximeter. So this is the probe model 3300 XL having 8 mm of trip and accepting through the proximeter module. So we will select this one. Now we will configure the range. So let's say 0 to 200 minimum peak to peak. This is the ideal gap range, -24 volt DC. We need not to change it anything. Okay, recorder output. Okay, we need not to select anything for this one. Okay, this is the alarm range, first alarm having delay of 3 seconds, and this is the second danger alarm level, means we can set as high range. Okay, having 1 second of delay. We can minimize it also. Minimum value is 1 and maximum value is 60 seconds. Okay, if we want to select the 100 ms, then we can select the 100 millisecond delay. It will be disabled. Okay, this is the alarm mode. So if you want to latch the alarm once it appears, then click on the latching. If you don't want, then non-latching. So latching is best. Second one is danger. Same thing for the latching and non-latching. Okay. Transducer orientation. This is the very important point. We need to set the degree of angle where probe is mounted. So we have mounted the two probes to measure the radial vibration either of the 45 degrees from left and right. Okay, so this is the 45 degree left side. Okay, this is the barrier option if you are accepting the proximity input through the barrier or not. So if the area is not hazardous, then we don't want to use the barrier. If area is hazardous, then from these two, one must be there available. Okay, so press on the OK. Okay, press OK. It is saying that we have converted into million. There is no problem. Okay. Okay, so if you want to copy the same configuration to this channel also, then we need to press the copy option. Okay, so we have pressed the copy option. So whatever the configuration was in first channel, it is already appeared in second channel also. Okay, degree of orientation, alert, danger, type of probe, range, gap voltage, etc. Okay, so similarly you can configure channel 3, channel 4 for turbine rear bearing, and similarly you can configure the slot number 3, which is having default properties. This channel we can configure for the generator side, generator left, generator front left, generator front right, generator rear left, generator rear right. Okay, so I will not repeat the same steps. Okay, next suppose we need to monitor the position. Okay, like differential expansion and axial position. At that time we need to select the position monitor. Okay, so if we select the position monitor, right click, put the options as it is, point names, whatever you want, set the options, click on the options. First here check that is it is configured for the differential expansion having two probes. So we need to set the default properties like zero position of the first probe. So here we can set it as -10 or -9.75. Second one is full scale range. So 0.25 to 0.25 inch. If we are having 5 mm to 5 mm, then we can set it here. Okay, gap voltage will be same, -24 DC. Okay, here is the important point, 25 mm extended range proximeter. So whatever the proximeter we have connected for measuring, we need to set that. Suppose we will select 3300 XL 50 mm proximeter. Okay, same alert and danger. Yeah, this is the important point, upscale direction. Either it is probe will indicate the positive when positive reading when the turbine rotor approaches towards the probe. If we want to decrease the output, then we need to select the away from probe. Next one is latching, non-latching. Okay, alarm mode, danger mode, latching, non-latching. We can put it as latching. Okay, press OK. Yeah. Similarly, configure the second probe also. Press OK. Now for axial, now for configuring the casing expansion. So let's say there is only one LVDT. We are configuring for the measurement of casing expansion. So we need to set the casing expansion single. If you have double, then we can set it as pair. Okay, we will select the casing expansion single LVDT option, and channel 4 will not be active in this case since we are using the single. We need to set the options. So here there are multiple LVDTs options are available. So we can put the LVDT same installed in the field. So suppose 2-inch of LVDT having model 135613 ST LVDT is installed in the field. Then we need to select this one. So automatically range will change. First it was 0 to 1 inch. After selecting this, it is converted to the 0 to 2 inch. Okay, position will be same, -10 to 10 volt. Okay, we need not to clamp the output value. Okay, this is the delay and danger value. So if alarm appears, we can increase the delay and also decrease the delay. Put the delay time as per your requirement. Okay, not okay channel defeat. This must be disabled. Okay, not okay mode, non-latching, alert mode latching, danger mode latching. These are the alarm LEDs on the IO module. Press OK. So here we have accepted vibrations and position. Now we will add the Phasor module, which is monitoring the phase angle of the turbine. So let's say we are having only one probe in the turbine section. So we will configure it in either upper or lower region. So we will select it in upper. So in one module we can configure the 2 channels. Click on option. Point names, you need to configure the point names. In second one, options, click on that. Okay, this IO module, Phasor IO module, internal termination. So if there is any external conditioning module, then we need to select that one. So if the area is not hazardous, then only internal termination is sufficient. So Phasor IO module, internal termination. Channel 2 we will disable since we are having only one probe installed. We will configure the channel 1 only. So threshold we need to put it in auto. Phasor signal. So this is the signal polarity. Either we are measuring the Phasor through the notch type or projection type. Second one is we are accepting the input through the proximity module or any magnetic sensors. Okay, this is the event setup, events per revolution. So we need to put the value same as that of number of speed gear teeth. So if speed gear having 50 teeth, then we need to put the value as 50. If it is having 60, then we need to put the 60. This is the hysteresis value. We need not to change it. This is the default configuration. Okay, this is the orientation, degree of orientation. So it is mounted. Currently it is showing as 0 degree, means it is at the top. If we install the probe 50 degrees to the left, then we need to input value as 50 to the left. If we have put the if we have installed the Phasor probe 50 degree right of the turbine, then we need to select the 50° right. Okay, so we will put as 0. Now this is the upper RPM limit. Configure it as per your requirement. Currently I am putting the same 999. Press OK. Now we will configure the output modules, that is alarming module. So click on relays and add the 32 standard relay module. Okay, it is having 4 channel, so it will be, let's configure this module also. Put the point name as per your requirement. Click on the options. So 1, 2, 3, 4. From these modules, we need to generate the output bit, that is output tripping bit, for whatever the set point we have selected. Up till now we have not selected any set point, so we will configure the set point first. Click on set points. First we need to cross check the range. So we will now check the range. Go to options, click on channel 1 options. So here the range is 0 to 10 millivolt peak to peak. Okay. So we will give the alarm value (10). So we will give the alarm value to 5. This enable tick must be here. If we remove this tick, then alarming option will be disabled. Okay. So we have put it in enable option. This is the danger limit, that is trip limit. So we will put it as 8. So this is configured for the channel 1. Similarly, channel 2, channel 3 and channel 4 we can set. So again we will set for channel 2. This is the 3. We will put it as 5 and this will be 8. Press OK. Now we will add this configuration to relay module. So we will select first the module from where we need to add the tripping bit. So we have selected the slot number 2. Slot number 2, channel number 1 and danger limit. This is slot 2, channel 1, danger. Okay, we will set it here. Press enter. So here the alarm trigger logic will appear. Again we will add 1 or 2 more conditions for tripping. So click on OR. If any of the bit gets high, then this output will be energized. So again we will add slot 2, channel 2, danger limit. Press enter. So we have added the turbine front bearing left side and right side bit in channel number 1. Similarly, in channel number 2 we can configure the third and fourth option. Slot 2, channel 3, danger, slot 2, channel 4, danger. So similarly we can configure the channel 3, channel 4 for generator front bearing and generator rear bearing also. And we need to click OK. So here we have added the turbine tripping bits condition. Now if we want to generate an alarm also, then we can add normal relay modules having 16 channel. So here 16 inputs can be added, similar with what we have done the configuration in the 6 number. So click on the same slot number 2, alert 1, press OK. Alert 1. Okay, it is already appeared. Or channel 2, alert, press OK. So similarly we can configure the 16 channels from here, channel 1, channel 2, channel 3 up to channel 16. Configure the set point limit as per your requirement and add that bits in this configuration. And finally, if we want to communicate this data with the DCS, then we can physically lay the hard wires and communicate with DCS for this output in the form of 4 to 20 milliampere, and for digital in the form of digital bits 0 or 1. If we want to communicate this rack to the DCS module through serial interface, then we need to add gateway. Select any one of the default gateway, double click on that, right click on that, go to options. Here communication gateway, IO dual RS232 422 port. So whatever the IO module is available, we need to select that one. Okay, communication gateway IO dual RS485. Nowadays RS485 is mostly used, so we will select the dual DB9 port having RS485 configuration. Okay, so here we need to configure the 2 ports. So if DCS is accepting the redundant configuration, then we need to configure port 1 and port 2. If DCS is only taking only one port, then we need to deactivate the second port. So this is the address of this communication module. Second one is word swap configuration allowed. Keep as it is. Okay. Now this is the full scale data range. So in which format the data will be transferred. So this is the 2 raised to power 16 format. Okay. Then we need to configure some communication setting, that is parity, even, odd or none. So select the parity as even or odd. It will be checked during the communication. Now stop bits. 2 stop bit will increase the loading on the system. So select only one stop bit for checking the CRC, cyclic redundancy checks. Okay, and this is the last baud rate. Okay, from 9600, 1200, 2400, 4800, 96,000, 19.2 kbps, 38.4 kbps. Out of this, select any one. So we will put it as 9600. Now we need to configure the addresses for this. Okay, so we need to click on this. Now select the second option, second module, which is for vibration purpose. Click on channel 1 and give the status point here. Okay, so at address of 46002 slot 2 channel 1 status. This is the digital status we have configured. Okay, same, this address must be configured at the DCS side also with the default setting, serial setting, which we have previously configured in this module. And this is the analog values of channel 1, channel 2, channel 3, channel 4 configured at address 3, 4, 5, 6, 7, 8 and 9, 10. Similarly, you can add the multiple addresses here and form one list in Excel having the address along with its description and give it to the DCS vendor for configuring the same. Press OK. Now this is the small rack having some 8 vibration probes, 1 and 2 differential expansion probe, casing expansion probe, relay output module and communication gateway module. Depending on your requirement, the rack size will increase if the IO count is more. For smaller turbines or smaller pumps, the IO count will be in between 5 to 10 only. Here you can configure the same in this manner. So here some are the shortcuts available. I will explain it also. So whatever the configuration we have done, we need to save it. Save it in any drive. Give some name. And save it. Okay, configuration is saved. This is the configuration done offline. So for downloading this configuration, we need to click on the download symbol. Before that, we need to connect to the existing rack with 3500 rack configuration software. For this, connecting the 3500 system with existing rack, I have already uploaded one video regarding that. You can see that, and you need to press the download for the implementation of this rack. Thanks for watching. Share and comment for the betterment of the videos. Thank you.